Here we are going to do the eighth question of exercise 6.2. Let's read the question. Using theorem 6.2, prove that line joining the midpoints of any two sides of a triangle is parallel to third side. Recall that you have done it in class 9. Okay. This theorem in class 9 is called midpoint theorem, and theorem 6.2 is converse of basic proportionality theorem. Let's start. Okay. Theorem 6.2, converse of BPT. Okay, converse of basic proportionality theorem, and the above statement is of midpoint theorem. So we need to prove midpoint theorem using theorem 6.2, that is converse of BPT. Let's start. There is a triangle drawn. Given that triangle ABC, condition number 1 is given condition P is the midpoint of AB. Okay, and Q is the midpoint of AC. We need to prove PQ parallel to BC. We need to prove PQ parallel to BC. Okay, let's start. Okay, in triangle ABC, P is the midpoint of AB. Okay, so we can write AP is equal to BP. AP is equal to BP. So AP by BP is equal to 1. This is taken as equation number 1. And Q is the midpoint of AC. Q is the midpoint of AC. So we can write AQ is equal to CQ. AQ is equal to CQ. So let's write AQ by CQ is equal to 1. So equation number 2. Comparing 1 and 2, the RHS are the same. So we can equate the LHS. Comparing 1 and 2, we get AP by BP is equal to AQ by CQ. AP by BP is equal to AQ by CQ. Here AP by BP is equal to AQ by CQ. Converse of midpoint theorem, that is theorem 6.2, says that if sides are divided in the same ratio by a line, then that line is parallel to BC, parallel to the third side. Okay, here AP by BP is equal to AQ by CQ. We can say that by the converse of midpoint theorem, PQ parallel to BC. So by 6.2 theorem, converse of BPT, okay, we can say that PQ parallel to BC. Hence proved. Thank you.